Okay, good news. Using scikit-learn to do k-means clustering is really easy. I'll just show you some code and we'll run through an example together. So I am going to use the famous Palmer penguin set. It contains a bunch of measurements. It also contains penguin species. I'm just going to take the measurements and I'm going to do k-means clustering. Now, k-means clustering will work. I mean, it's possible to have, really bad data sets that somehow break things. But the point I'm trying to make is that I can say I want to find two clusters and k-means clustering, I can do it. I can say I want three clusters. I can say I want four clusters. I can say I want 17 clusters. So we really need to go into a problem with some idea of how many clusters we think we're looking for. And the answer to how many clusters are we looking for does not have a concrete right or wrong answer. Um, in this particular case, I do know that there are three different species of penguins, and I wonder if I look for three clusters, will I be able to see those species? That is to say, will k-means clustering identify species for me? Um, let's find out. So we load our data. We only need the numerical data for k-means clustering. In fact, we can't do it with categorical data. So we select our numerical data and we get rid of our species. We drop NaN values. This code will give us an error message if we don't do that. We scale our data. We have seen a standard scaler before. Because k-means clustering is based on a distance, dimensions with large distances in them can dominate the data. So we use standard scaler and we define Z. Z is our data scaled. And one thing I like about this library is that they do not mess around and make things difficult. How do we perform k-means clustering? Well, we use k-means. We tell it how many clusters we want. This is just for reproducibility. This is setting a seed. This we could get rid of. This is so by default, we're using k-means plus plus here. And that is what we're doing. I have not done anything in this code that would change that. Um, if you use k-means plus plus, the algorithm runs once. If you use random, just completely random chance to situate your initial centroid centroids, then the algorithm will run 10 times. I've already mentioned that in a separate video. And that behavior is being stored here. That is the auto behavior. So I have it in my code. I could delete it. It's not really, this is the default, so it's not really doing anything. But anyway, we run these two lines of code and we've done our clustering just like that. That will produce labels. Well, let me just run this so I can show you. That will produce labels. So our clusters are numbered 0, 1, and 2. And this is saying, well, the first penguin in Z is in cluster 0. The second penguin in Z is in cluster 0. That's kind of inconvenient. So we take this and we append it to Z. So now Z has all of this information scaled, and it also has the cluster attached. And all that's left to do is to take a look. I asked whether this clustering behavior would identify penguin species. I'm cheating with this code. I mean, I ran the code first, and that's how I know, first of all, that it is doing what I think it will do, which is sort of find species. And that's how I know that cluster 0 is going to more or less correspond to Adelie, and that's how I could hard code this in. I did not know this the first time I ran it. But we see here are the species, here are k-means clustering. And the k-means clustering did not perfectly find the species. It did quite a good job of finding the Gentoo penguins. It did a slightly worse job of distinguishing between the Adelie and chinstrap penguins. And there are four dimensions, right? When I create the scatter plot, necessarily I can only show this in 2 dimensions. So you might be looking at this and you might see this chinstrap penguin, and you might see that over here, k-means clustering has successfully identified this. And you might wonder, how's that happening? Isn't this penguin closer to the center of this data set than it is to the center of this data set? Um, if you could look at all 4 dimensions, that would stop being the case. It looks like that, but it only looks that way because when we graph this, we can only graph it in 2 dimensions. And I mean, I've got the code on Canvas. Let me check my notes if there's anything I'm obviously missing here. I don't think there is. Um, So I'll end this video. I mean, I guess I should emphasize, k-means clustering is unsupervised. There are no labels in the data. So in this particular case, the clusters I found correspond pretty clearly to some kind of real world quantity. In this particular case, they correspond clearly to the actual species. But, there's no guarantee. I mean, obviously, my scatter plots have now completely broken because my scatter plots had this stuff hard coded in. But the point I was trying to make is that you can tell k-means clustering, I want 30 clusters, and it does it. And do these clusters mean anything? Probably not. Not totally clear. Um, so so the number of clusters we use is a decision that we are making. And sometimes one number might make more sense than another number, but there's not necessarily one correct answer. And I'll talk about that a little more in a later video.